Hello students, in this video we are going to work on a problem which can't be solved by factoring. This is not in quadratic form and we are not able to apply any trigonometric identity as well. So how to go about this type of problem? So for this we are going to square both the sides. So we started by squaring both the sides. Now apply a minus b whole square identity. Let me write the identity here. It's a squared, a minus b whole squared equals a squared plus b squared minus 2ab. Using this identity, we get sine square theta plus b is 1 minus 2 times sine theta times 1 equals square of cos theta is cos square theta. Now we can apply the Pythagorean identity. We can replace either sine square theta or cos square theta. But since this is a single term is in form of sine theta, so better to replace cos square theta in terms of sine square theta, so that we get the whole equation in terms of sine theta. Using the Pythagorean identity, we know that cos square theta equals 1 minus sine square theta. Now we can combine the like terms. 2 sine theta, this one get cancelled from both sides and this equals 0. Combining these two terms, we get 2 sine square theta minus 2 sine theta equals 0. Now we can solve it by factoring. Factor out 2 sine theta here. Inside we get sine theta minus 1, and now by zero product rule we can set each factor equals to 0. 2 sine theta equals 0 and the other factor sine theta minus 1 equals 0, and solve them for theta. Here we get sine theta equals 0 and here we get sine theta equals 1. Now we have to see where sine theta is 0. We know that sine theta is 0 at each pi. Sine theta is 0 at 0, pi, 2 pi, 3 pi and so on. So we can write, if we want the solutions in one period from 0 to 2 pi, then we write these as 0, pi, 2 pi. So we have 3 solutions in one period. For sine theta equals 1, we know that sine has value 1 at pi over 2. So it has only one solution in one period. Theta equals pi over 2. Now since we solved it by squaring both the sides, so we have to check some extraneous solutions. There might be some extraneous solutions, so let's check them. For that, we plug in these solutions into the original equations one by one. So we had the original equation as sine theta minus 1 equals cos theta. This is the check we are going to apply here. Now plug in 0. We are going to check first solution. Sine 0 minus 1 equals cos 0. Sine 0 is 0 minus 1 equals cos 0 is 1. So negative 1 is not equal to 1. So we are not going to use this solution. Next we are going to check pi. Sine pi minus 1 equals cos pi. Sine pi is 0 minus 1 equals cos pi is negative 1. Negative 1 equals negative 1. So this is working. We are going to accept this solution. Next we are going to check 2 pi. Sine 2 pi minus 1 equals cos 2 pi. Sine 2 pi is 0 minus 1 equals cos 2 pi is 1. So again we get negative 1 equals 1, which is not acceptable. So again this is not the solution. So we get only one solution. Out of 3 solutions, the only correct solution is pi. For this equation, we got the 2 solutions, pi and pi over 2. From the first part, we got pi. From the second, we got pi over 2. These are the solution of given trigonometric equation in one period. And if you want to write the general solution, so we just add 2k pi. Since the period of sine and cos is 2 pi, so we are going to add the multiple of 2 pi, which is 2k pi. And the other solution is pi over 2 plus 2k pi, where k is any positive or negative integer. So this is the general solution, or which represent all the solutions. I hope you understood this problem. See you later. Bye bye.